How do you design your rocket?
The way that we kind of started going about designing the rocket was it was off the back of our success at Race to Space and having an engine that works. We kind of spoke about some of the other shortcomings from the year before, where we kind of felt that we'd missed out on EuRoC because of maybe a little bit of lack of innovation from the team. So we started off as a discussion about, one, how can we kind of piggyback off of this recent success that we have, whilst also, maximizing our chances of actually making it into EuRoC. So that's at that point we decided that the main focus of the rocket this year would be using the hybrid engine. At that point, we also, because of the modeling that I spoke about before, we're relatively confident that we could use the engine to make a vehicle capable of 9,000 meters. That was the first point where conceptually we were like, we want a 9,000 meter hybrid vehicle. Then from there, it was also looking a lot about the budget that we could secure from the uni. So at that point, with the budget that we knew that carbon fiber was probably not possible. So then we've gone for a fiberglass semi-monocoque. And from there, as the designs become more, has become more solidified. So even this last couple of weeks, we've decided to integrate oxidizer tank into the wall of the vehicle. So the tank itself will be carrying the loads from the engine, how it works in real rockets. So we thought, why shouldn't we be able to do it? So a lot of it has been kind of exploring a certain development path until we get stuck, and then maybe shifting to a slightly different one until they get stuck on that one. A good amount of trial and error. If we had a slightly larger team, perhaps we could, explore a couple of these different opportunities. But instead, we kind of keep on going. But it does leave a lot of development paths for the next couple of years as well.
Yeah, it's been quite an iterative process. We've been building on various designs made over the past couple of years. So, for example, our air brake system, which is what slows the rocket down to hit that 9,000 meter target. It was designed for the rocket. That was built for EuRoC 2022, but obviously it never flew, so we didn't get any data from that. But we built off that design and another design that we made for EuRoC during our GBDP competition. We sort of merged those designs and scaled it up. And then our recovery system is a complete redesign. But sort of the hybrid we've iterated. It's a similar Aerospike design and layout to what we designed for Race to Space over the summer, but it's bigger and it's got some improvements. So yeah, we've been sort of iterating towards the final design.
A lot of the, even though the vehicle itself is quite different to anything we've done before, a lot of the actual designs are evolutions of things we've done before, more than anything else.
Yeah, it's bigger. That's been a challenge. It's a lot bigger. It's 2 times longer and almost twice the diameter of all our previous rockets. So we've been running into sort of constraints with simply what can be manufactured at the university that we hadn't met in the past. So, for example, the university can only index tubes up to 1 meter long, which wasn't a problem before, and now it is a problem because our tank can only be 1 meter long. So things like that have been a challenge. But
so your engine uses an Aerospike.
I've actually got an example here. Rear section of the engine that we tested at Race to Space is actually the test article. It's partially disassembled, but I hope you can see clearly enough there the Aerospike.
Yeah, I can see it.
Added to this, or you can look on our LinkedIn. Yeah, that was the result of a final year project developing that 2 years ago, I believe, or last year. Anyway, that's a graphite Aerospike that we get machined at a company nearby. Yeah, we're quite excited about it. Obviously, it's new to the team, but it brings some benefits. Do you want to just talk through the Aerospike, I guess?
Yeah, I mean, we're using a truncated Aerospike, as you can imagine. At Race to Space, we were the only Aerospike engine. I believe we're possibly the first UK Aerospike, although I'm not.
Yeah, so there is another team developing one as well this year. So we'll be curious to see how they've gone about doing it.
Yeah,
not seen yet.
So last year at the test, one of our real big issues was there's some braces that hold on the Aerospike, and these cause stagnation points in the flow. And we saw really bad erosion of our insulating material at those points. And that's why this year we have somebody whose whole focus is insulating materials in the post-combustion chamber, because we're looking to rectify that. Otherwise, we won't be able to make our full burn times.
And you can see that's the Aerospike there. The one we've got this year is going to be, I think it's about twice as long and a little bit wider in diameter. But we haven't machined the new one yet, so that's the old one. And then that's how it's mounted in the engine. These are the stagnation points that Ben mentioned inside the engine. That holder gets really hot. So we're trying to figure out how we can cool that effectively.
I assume the holders are aerofoil shaped, right?
In the test article, they were not, just because of machining constraints. In the new one, they are going to be a little bit differently shaped. There's still some optimization going on there with the cooling.
The main concern with having them aerofoil shaped is that shape might be completely lost once you've applied the insulating material. And at that point, if we want to make them aerofoil shaped, they'll be quite thin. So we're currently kind of trying to weigh up the benefits and drawbacks between having them just a round shape versus an aerofoil shape once we have the insulation on.
Did Merlin also look at angled ones as well?
Yeah, we looked at angled. We looked at angled ones.
We've played around with ideas such as angling them as well to sort of get different flow characteristics. But no plans to do that so far.
How do you test and measure the performance of your engine or rocket?
Well, we currently don't have a lot of data because, sadly, the rocket wasn't able to fly at EuRoC a couple of years ago. We are hoping to get more data this time around. I guess our main source of engine data is that race to space competition. So the company there it's really good. They set up the whole thing for us and the other teams, and they provide data acquisition software.
The main data that we collected there last year was just thrust data through a load cell. But we also had injector feed pressure data, I believe. So this helped us model the pressure drop over our injector and how it translates to thrust. So we used that to model our efficiency, which is proving quite helpful for this year. Those are the main sources of data. On the vehicle itself, data acquisition will come through just onboard GPS circuits and IMUs, things like that.
Yeah, I'm not sure what specific data acquisition method they're going to be using on the rocket. So I'm afraid I can't tell you that. Yeah, we're hoping to gather a bit more data at Race to Space as well this year. Thermal data around the engine, stress data, we'll put some strain gauges on the outside of the engine as well. The difference is last year, the engine we used at the competition was very much a test article. But this year, obviously, we're going to be testing a flight-ready engine. So there's a whole host of data we need to gather for that that we can present to EuRoC. And sort of hopefully show that the engine is safe. In terms of where that test is, by the way, I should mention it's a company called Airborne Engineering. They're very helpful in setting up all the testing and giving us the opportunity, obviously through the Race to Space competition and just general testing days when we need them.